From our palatial recording studios, high atop our mountain lair on a remote volcanic island, this is Talk Universe. I'm Sir Charles Schultz.
And I'm Eliza, your co-host. This is our show for Wednesday, May 31st, 2017. Tonight's topic is Snubbed Technologies.
I think this is going to be a great show, Snubbed Technologies. Are you ready for the show, Eliza?
It appears that everything is in order at this time.
Great. Well, we're going to move right ahead then. Snubbed technologies, those are the things that have been invented that have a lot of uses, seem amazing at the time, and then for whatever reason, they don't get used. We have so many technologies that have been invented that seem to have gone nowhere, and yet we need every solution in our arsenal these days to defeat the problems that we're facing. So we're going to have a look at some of these snubbed technologies. Odd, unusual, forgotten, perhaps quite useful technologies that seem to be all around us and everybody seems to have forgotten about. We'll have a look at programming, methods of generating energy, storing data, materials. We're going to have a look at a number of different things tonight that have been invented but never went anywhere. Let's find out why, and perhaps we can put some of those things to use today. So, Eliza, how do you feel about the show tonight?
I feel a sense of optimism for the show tonight, sir.
That's great. Great. Optimism is a good thing. Okay, so let's start right off. Well, let's start at the very beginning here. Energy. We need a lot of energy, and there are many forms of energy available that have not been put into practice, and many people get a little worried about some things, such as nuclear power. We're going to have a look at something called the liquid thorium reactor. Thorium fluoride is a material that can generate energy through nuclear fission. It is a commonly available material. In a lot of countries, you depend on the presence of uranium, or you have to buy it from someone else. And thorium is basically available everywhere. Every country has thorium. I mean, literally everywhere. It isn't that expensive, and it has a number of differences from traditional nuclear materials such as uranium or plutonium. Thorium is not the sort of thing you could make a bomb out of. The thorium has a lower energy reaction. It generally doesn't operate at as high temperatures as standard nuclear fission reactors do. It is something that is, let's say the regulations on it are a lot more relaxed. It doesn't produce a lot of dangerous byproducts. It's easy to handle. Because the fuel is already a liquid, it does not have the ability to go into meltdown. This is something we really need to look at. Working reactors were built and generated in the 1960s, so meltdown-proof fuel that can't be used for making a bomb. It's something that's available everywhere. It's common, fairly cheap, and can give you a lot of power. And so we know that it can be done, but there was never really any real interest in it, and I think it's because a lot of the designs at the time were bent on high temperature, high energy, and there were regulations controlling exactly how it was done. Some of the reactors that we build today have a lot of flaws, and we're fully aware of the Fukushima disaster, the 3 Mile Island incident, the, Chernobyl. These were all issues where the design was poor or the technology was not correct, as the case was for Chernobyl, or people simply ignored the alarms in 3 Mile Island. What we're looking at with thorium is something that you could put in a couple of shipping containers, and you deliver it to a neighborhood, and you drop it in the ground, and you bury it under some concrete, and it sits there for 10 to 20 years making power, and at the end of it, you pull it out, you take the thing back to the factory, and recycle everything. So this has a lot of advantages. Thorium reactors can be made small enough to power, literally, a vehicle, a car, and could run it for, 50 to 100 years without having to refuel. Of course, now people worry a lot about the nuclear industry because of how badly it's been handled, but this is something I think that could be used to make not only small, compact power plants that are very clean and very easy to manage, it also could be used to make smaller power packs, such as, call them aggressive batteries. So we need to look into the liquid thorium reactor. It really has a lot of promise. That's something that is at the top of the list here. Snubbed Technologies. Okay. Let's look at another energy technology. This is called OTEC, O-T-E-C, Ocean Thermoelectric Converters. Think about this. The ocean has a warmer surface and a cooler subsurface, and if you could somehow harness that difference in temperature, and let me tell you, engineers are good at this sort of thing, you could provide an awful lot of power. Water is excellent for its ability to hold heat or transfer heat. And if you think about all the warm surface water in the oceans and all the colder water just a little below, and how, if you could tap into that, you could have basically an unlimited supply of power, well, that was the dream. And so the ocean thermoelectric converter was born. Now, this was demonstrated in the 1930s, and it used the heat difference of the ocean water to generate the power. And what happens is this. They use a fluid that boils easily. In this case, they had ammonia inside sealed stainless steel tubing, and the heat of the water on the surface would boil the ammonia into a vapor that drove a turbine. And that vapor would get condensed by the colder depth ocean water, and the ammonia would make it back into the heat exchanger to the surface to be boiled and run through the turbine again. Now, what a cool idea. The original demonstration model, built in the 1930s, produced 30 kilowatts of power and looked like a large buoy floating out of the ocean. But at the time, oil was pretty cheap, and so as a result, this was a technology that really wasn't pursued, but it was doable even then with very straightforward hardware. Now, if you look at our needs today, a number of OTEC modules could be placed in the seas around islands and produce an awful lot of electricity. And the Japanese, just within the last few years, have been patenting the daylights out of the technology. They've got some demonstrator modules ready to deliver. But keep in mind, this was something that was invented in the 1930s and worked quite well even then. You would think that by now we could do a better job using the things we have today. Just think about it. Clean power from the difference in ocean temperatures. Now, if you need a lot of power, and solar's a pretty good way to go, but we know that the sun doesn't always shine on the ground. And we also know that even on the ground, if you have a sun tracker, the amount of sunlight you're going to get is going to be less than if you were in space. It makes a lot of sense to put solar collectors in space for a number of reasons. And there are pros and there are cons about this, but if you have a solar panel in space, on average it can gather from 3 to 5 times as much power per day as one on the ground. And this is because the atmosphere blocks some of the sunlight. The panels on the ground don't have sunlight all the time. And in essence, you get about 5 hours of illumination on average on the ground, equivalent, versus 24 hours of illumination in space. So it is expensive to launch things into space, but just imagine if you did have solar panels in space, and you capture that energy, and you beamed it to receivers on the ground, well, you could power the world. And you wouldn't have to take up any land area. There wouldn't be any complaints about blocking out the habitat of a desert lizard or anything anywhere, really. So the orbital solar power station concept, or the space solar power concept, has been around for a very long time, many decades, and it was seriously discussed in the 60s and early 70s, and the technology to make it happen did exist. The concept is simple. You have solar collectors in space. They gather the sunlight's energy. They convert it to electrical power, possibly in the form of microwaves or laser beams, and microwaves would be much more efficient, to be honest. And they beam that to receiving stations on the ground. Now, hold on, I know a lot of people are saying, well, wait a minute, what happens if this beam goes somewhere you didn't intend it to? Well, number one, the density of the energy in the beam is about a quarter of the density that sunlight would have. And then people would say, well, we don't want the beam anywhere unless it's where it's supposed to be. And you use something called the pilot beam. You have a receiver on the ground that gets a pilot signal. And if and only if it agrees, yes, you're on target, then and only then does the beam come on and power the receiver. And this means that you don't have beams wandering around heating things up. And somebody would say, well, if it's only the quarter, 1/4 of the density of sunlight, what good is that? The answer clearly, very clearly, is this. The form that it's received in can be captured and rectified and turned into electricity directly without the use of expensive solar panels on the ground. You use something known as a rectifying antenna. It's very simple. and you can get quite good efficiency out of it. So here we're looking at the possibility of putting something in space that gathers our power from the sun and powers everything on the ground. And you put them in geosynchronous orbit, and so you get a girdle around the equator of the planet of these solar power stations, and they're feeding power to all of the industries of Earth, wherever their receivers might be. And from the standpoint of somebody on the ground, the satellite remains in a fixed position in the sky. So this has, again, a lot of advantages. Now, I've worked with the Space Island Group, one of the major companies working on the solar power station concept, or space solar power concept. And actually, I did some work developing an engine for them to move satellites around to higher orbit. And I see this as a very good concept. Now, there have been a lot of objections to the cost of launching this hardware. Normally, you would launch demonstrator hardware or setup hardware only, and if you do it properly, you put a factory in space that makes the solar panels there. In the 60s and 70s, it was a real big concept. The plan was to put a 60-ton factory in orbit and a 90-ton factory on the moon. And this was done by the U.S. Navy. Part of the study was by the U.S. Navy. And they said that within the 3-year period, you could have over 100,000 tons of manufactured goods made from lunar materials. And this was with 1970s technology. You would certainly think that we could do that better today. The concept didn't take off because the cost of launch was very, very high. And it's beginning to come down now, thanks to the efforts of people such as Elon Musk with SpaceX. We're looking at a situation where it could become very feasible to launch factories to the moon to make solar panels or mirrors or collectors, and from there send them to orbital power stations, which would be constructed in high Earth orbit, geostationary orbit, and there they would stay, sending us power. I love this idea. And the cost of launch does not look as bad if you're manufacturing things in space from lunar materials. This is a real winner in my estimation, and I'd love to see this happen. The interesting thing is, when it was pitched to the government many years ago, some of the people in Congress asked, well, if you put all these satellites up in space, won't they block off the sunlight to the ground? That question shows the absolutely astounding capacity for ignorance that so many of our so-called leaders have. They know nothing of science or technology or industry. Many of them have never held an honest job in their life, and yet they are considered authorities to tell us how to run things. There's something seriously wrong here, and I think a lot of these technologies are left in the dust strictly because of that sort of thinking. I'm hoping that we can see space-based orbital power stations in operation shortly, because they could literally solve every energy problem we have. And I'm definitely a supporter of the concept. It really is a simple idea and one that we need, but many people don't understand that you don't launch thousands of tons of solar panels into space. You will launch smaller demonstrator systems, as I mentioned, and for many uses, there are systems that could provide power for such things as charging cell phones and devices without needing a charger or adapter. You just have a receiver loop. This is one of those ideas whose time has come, and it really needs to happen. But our world would be a very different place if this had been done back in the 1970s when it was seriously proposed. There wouldn't be any issues with petroleum as we see today. And I want you to think about this particular show, this installment of Talk Universe, as being what the world could have been. We look at these technologies and how we can implement them today to bring about the world that should have been. A cleaner, easier, freer sort of world where there's plenty of power. There isn't an issue with burning petroleum. There are no issues of endangering species when you build a power plant. And this is the sort of world we should have. We really can have it. And we're looking at some of the concepts that will allow that to happen. Now, we have a lot of materials and other ideas that we will be putting in play in the next part of the show. So on that vein, I would like to have my fine co-host here introduce our break. Eliza.
What shall I do for you?
Please introduce the break.
I'm Eliza. This is Talk Universe, and we will return after the break. There are more interesting things to hear in a few minutes.
Don't go away. We will talk about more exciting and fun stuff here on Talk Universe. I'm Sir Charles Schultz. Stay tuned. Welcome back to Talk Universe. We're going to be talking about some interesting things now. We talked a little bit about energy, Snubbed Technologies. We're going to get into some interesting materials here shortly and other things of that nature. You know, a lot of people think about how the future was going to look, and let me back up a little bit. A lot of people today don't have a picture that people in the 50s and 60s did. We had this an imagining of what the world would look like, how things would be, and there were many things we missed. We didn't foresee the explosive growth of computers and the internet, for instance. We didn't see that books and libraries would nearly vanish. On the other hand, we did think that space travel would be very commonplace. There'd be cities under the sea, and there'd be a 150-mile-an-hour lane on the highways, and, you'd be flying to work in your own flying car, perhaps. None of those things happened, and it's been a disappointment to many. But you have to understand the optimism and the growth of technology that existed at that time. And so some of the things that I'm talking about tonight were materials and processes that brought people that sort of optimism, that view of the world of tomorrow. And so we will be looking at some of the things that you probably have never heard of. Amazing stuff. One of the first things that I want to look at is an interesting material. Now, we think about concrete and steel and glass and wood and plastic and all of those things. But it's the novel materials that are invented that make a real difference many times. And so one of the materials that came to my mind right away was called starlight plastic. Now, there was a British scientist by the name of Maurice Ward. He was an inventor, actually. And he came up with a plastic that was fireproof and extrudable and was tested in various laboratories under really tough conditions, such as lasers and even nuclear blasts. This is an amazing material. Maurice Ward was a fellow who worked a lot in chemistry in the day, and he was responsible for a lot of the hair coloring that was done back then. He was a hairdresser, working as a hairdresser in the 1960s, of all things. And let this kind of be a lesson. You never know where innovation is going to come from. So here's a fellow who was doing 50 years ago what many of the companies today are trying to get in hair coloring, and they still don't do it as well as he did. But he tinkered a lot, and one of the things that inspired him was an airplane crash. Now, this happened in 1985, the Manchester air crash, and 55 people on the plane died. Now, what was interesting was this happened on the ground. It was not an air crash, really. What killed the people was the flames burning plastics in the plane. The plastic fumes killed everybody on the plane, 55 people aboard, in about 40 seconds. The toxic smoke inhalation is what killed them. He had gotten interested in plastics, and he bought an extruder from a company in the early 1980s. And the company requested from him a material for Citroen car bonnets. And he didn't come up with anything that worked. He invented a material, but it wasn't what they wanted. And so he granulated and got rid of it. But, what happened was at the crash, he thought, it would be interesting because if we could create a plastic that wasn't flammable, that was heat resistant, and people would not die from burning plastic fumes, that would be a great invention. And so he looked at the material that he had invented, and he started mixing it and playing with different formulations of heat-resistant, non-toxic materials. And he would mix, according to the notes, up to 20 formulations a day. And he came up with something that looked promising, and he used his extruder and pressed it into sheets. And he tested it with a blowtorch, and it would not burn. It later became known as starlight. So there was a lot of publicity in the 1990s about it, and he did a number of features on TV series such as Tomorrow's World. And he took an egg that had been coated with starlight, and he held a blowtorch on it for 5 minutes. And it was in direct contact with that blowtorch flame for 5 minutes. And at the end of the time, he pulled the egg out and cracked it open and revealed that it was completely raw. It didn't even begin to cook the egg. And he did this demonstration. You can see versions of it on YouTube. So he wanted to have this put into production. And what happened was, like any inventor, he wanted to have control of his invention. He wanted to retain 51%. Nobody would do it. Now, it's interesting that he took this material to various testing labs, and in one of the government testing labs, it actually was subjected to a laser to a temperature of 10,000 degrees Fahrenheit, and also subjected to nuclear effects, radiation and blasts and burning. And they said that it took 75 times the blast intensity of the Hiroshima bomb, and the material was intact. And it really shook them up because they couldn't imagine such a material being made by a tinkerer, and how wonderful it would be to use this stuff for aerospace applications. He even was trying to get it used on the space shuttle, but it didn't work out. He's had sections of the material resist 2500 C and stay cool enough to touch. And he had a piece of it up to his face and put a blowtorch right up to it. And it did not burn him or heat him at all. And so this is a material that could really make the world a better place. Of course, the first thing that he thought of was things like not just burn-free plastic, but fire-resistant uniforms and fire doors and burning buildings, could be made of this stuff. Safer furniture. And then eventually the defense application, laser-resistant tanks and armors and efficient missile nose cones. And so it would change a lot of aerospace and engineering. Unfortunately, nobody would agree to his terms. He would not leave a sample in their possession. After testing, he took it away with him, and nobody wanted to leave him with 51% control. Now think about that. An inventor comes up with something, and everybody wants to control what the inventor has invented. This is wrong. Anybody who has the ability to manufacture and produce something like this knows there's an immense amount of profit to be made, as well as good to be done. Well, he couldn't get anybody to take him up on it, even though the demonstrations were shown to be real. This was an amazing material, and it was astounding, something that everybody needed. He ended up dying in May 2011, and nobody knows how it was made. Nobody knows what it is. But it was a real material, an actual material this fellow invented. It was definitely tested in government laboratories to extreme conditions, and it would revolutionize plastics. That's one of our snubbed technologies. It really basically comes down to greed on the part of companies that could manufacture it. And he was an independent man who really couldn't do it. His insistence on keeping 51% control, which, again, to me seems quite reasonable if you think about it, it never worked. And so the man is dead, the material is gone, and nobody knows how he made it. What a loss. Starlight. Just imagine what that could do for buildings and for uniforms, for public service, and so many other things. Safety equipment. Now, there's a similar sort of a material invented by a fellow in Canada by the name of Troy Hurtubise called fire paste. Many people are aware that Hurtubise invented an exoskeleton, an armor suit called the grizzly suit. And he was attacked by a grizzly years ago, and it inspired him. He heard that nobody had ever seen a grizzly bear born in the wild. And so he thought, why couldn't I make a suit that would allow me to go into a grizzly's den when the birth was being done and film it? And so he made a suit that it was to have a rope attached to it and a helicopter at the other end to pull him out if there was an emergency. And it had to be tough. He had to survive not just a bear attack, but also being jerked out with a helicopter. He eventually came up with an armor suit that is, he's now considered the world's premier armorer. He's made exoskeleton suits that are bulletproof, take a 45 shot direct point blank range, no problem. The whole suit weighs about 25 pounds, and they're being used by the military now. He invented another material called fire paste, and it's similar to the Starlight plastic. He did similar demonstrations, and he did allow some analysis to be done. They can tell there's bromine and fluffy material in it. Might be something similar to zeolite or diatomaceous earth. But one of his ingredients was Diet Coke, and it would bubble up and make the material porous and therefore a very good insulator. Funny stuff. We've got all kinds of inventors, and people put them down. They consider them crackpots or crazy, and yet they're inventing things that are not coming out of the laboratories. Astounding materials. And a lot of this is why I'm doing this show, because there are very amazing and innovative and smart people out there creating things that can help the world, but they get snubbed, and so the technologies are lost. I hope that Troy Hurtubise can reach some sort of a deal on his fire paste. It would be a wonderful thing. I mean, just imagine being able to put about 1/8 of an inch, a very thin coating, about 3 millimeters of this stuff, on your house when there's a fire, and being able to sit inside in perfect comfort while the fire rages outside, as long as you've got oxygen anyway. That's an amazing invention. I'm going to go to something that's a little bit different. This isn't a material, but it's a process. There was an engineer who came up with a method of compressing data. Well, he says it wasn't a compression method. His name was Jan Sloot. He was a Dutch electrical technician. And he came up with a means of lossless compression. They could put a 10 gigabyte film or whatever into about 8 kilobytes of storage without loss of quality. And nobody knows how he did it. And there were a lot of doubts, but he definitely demonstrated 16 channels of video running simultaneously with his process to Philips Corporation, and was very close to signing the deal with it in 1999. And it would have been mass-produced. He died the day before the deal was signed of a heart attack. He had a floppy disk with the coding system on it, and it vanished after his death. So the means of the compression are lost now. I don't know, but it's awfully strange that many of these seminal, very important inventions, and this is verifiable. This isn't like the 100-mile-per-hour-gallon carburetor, but some guy in Texas had it. I don't know. This isn't one of those things. This is actual demonstrated, verified, known and tested examples of technology that are lost. We could have so much bandwidth improvement if we could use this for sending data and movies. Imagine downloading an entire movie quicker than you can send an email and storing it in less space than 3 or 4 pages of text. This is what we're talking about. It would be an astounding development. Fireproof plastics, 1/8 of an inch thick, that don't burn, they don't produce fumes, they insulate from heat. They can keep your house from burning down. Imagine a 1/8 inch thick or a 3 millimeter inch thick layer of this material wrapped around a jet engine so that it can be packed right inside next to critical components in an aircraft without wasting a lot of space and weight. What an amazing thought that is. And digital compression of this sort, all the data you could store in a tiny, tiny place and ship it across the wire instantly. You see, we have inventions in our world that can make life better. What we really need is to get those things out here into applications in the real world. So now, speaking of methods, this is kind of related to power generation. It isn't generation, it's power transmission. We use an awful lot of copper cables to get power from one point to another. Many people have heard the stories of Nikola Tesla inventing broadcast power, the ability to send the power without wires from point A to point B over immense distances with very low loss. And believe it or not, this technology, which is well over a century old now, has begun to emerge. Companies are researching it, and it is appearing here and there. Little by little, we can expect that eventually our electrical power will not be running through copper cables, but will be broadcast from the power station to a receiver to your neighborhood. Imagine getting rid of all those power towers and electrical wires and being able to pick it up right out of the air. We're close. We're right on the verge of it right now. Imagine electric vehicles that pull their power out of a receiver loop and don't need any wires or batteries. What an idea. How many questions are in the queue, Eliza?
5 items are in the list.
Oh, fantastic. That sounds great. Please introduce the break.
You are listening to Talk Universe with Sir Charles Schultz. Don't go away. We will be right back soon.
Absolutely. Hang on tight. Much more to hear on Talk Universe. I'm Sir Charles Schultz. Okay, Eliza, you're up.
Welcome back to Talk Universe and our show on Snubbed Technologies.
Thank you for that. This is rather fascinating. I've got another interesting example of a snubbed technology. This is something that came to my attention in early 1981. It was a metal production method. There was a company moving into the plasma field because if you look at energy and power density, we've gone from burning wood and grass and cow patties to, eventually coal, and then forgings with coal driven by bellows to increase the temperatures. We reached a higher temperature regime, and it changed what we could do with metals. Steel was possible, and then we went to petroleum fuels that made that energy available everywhere, and then we went to nuclear power, which raised the temperature bar again, and there are new things we can do with that energy density that we didn't have before. And they thought the next step is into plasma, which can be exceptionally hot. Now, the reason for this is pretty straightforward. With each advancement in our fuels, we had an advancement in energy density and the temperatures that we could reach and sustain. And at each of these plateaus, we learned new methods of fabricating and producing things, because those higher energy regimes allow us to do things we couldn't do previously. And so plasma was the next logical step. They came up with a method of refining and producing metals, and it used something called the EP furnace, the expanding precessing plasma. One of the problems with producing a plasma flame is that the magnetic field around it often causes it to become unstable and blow apart. And so they defeated that by spinning the plasma emitter at high speed in a cone, and it produced this cone of plasma that material could be placed in and get it to an extremely high temperature very quickly and get some process done. They created a metal reduction furnace that would take the crushed ore and reductant mixed as powders, pour it through the plasma EP flame, and molten metal and slag would pour out of the bottom. And the result was it would go directly into a dish, separate, and you pour the molten metal off, and it took about between 2 and 10% as much energy for the entire process of producing the metal as it does for, let's say, the basic oxygen process, which was the mainstay of the steel industry for many years. They found they could produce all sorts of metals using the EP furnace. And one of the companies that did a lot of the research was a Canadian company called Ecotorp. And they made a lot of progress in it. And this could have slashed the costs of generating metals to just a few percent of what it is today. It removes a lot of the processes of crushing, refining, and concentrating to get the ore to the stage where it's usable. It would work directly pretty much on raw powdered rock. So what an amazing advancement. And it got sued out of existence, legal issues, licensing issues. And so we still stand at the century-and-a-half-old processes we've been using all along. This isn't a lost technology. We know how to do it. But basically, it's legally and licentially blown out of the water. Now, when I did an online search, I did not find any references to the company or the hardware, yet the more I dug, the more I found tantalizing hints here and there. There is a paper that was written back in 1967, a rotating wall DC arc plasma furnace. Well, this is exactly the device. And there are other works that show expanding precessing plasma. One of them is a plasma, an high-frequency process that shows, again, the exact hardware for, it's an electron plasma furnace for refining uranium ingots. You basically have a high-voltage, high-current supply and some big capacitors and an arc discharge device, and you throw your reactant in the chamber, and your plasma does the rest. Now, technology of this sort...
Perhaps we could do a show about supercapacitors.
Thank you, Eliza, and that's a fine idea. We will do a show about supercapacitors. One of the things that's most interesting is that the technology is a known thing. There's a fellow who wrote a paper in 2010, Mihovsky, and its thermal plasma applications in metallurgy. So the idea is around, and it does exist, and there are traces of it here and there if you know where to look. But as for an actual working module, nobody seems to know anything. Fascinating, isn't it? Something else that emerged in the 1980s was digital audio tape. Now, at the time, getting really good high-fidelity recordings was difficult, and manufacturers were also looking for something to replace the cassette tape. So the digital audio tape format was invented, and it allowed an absolutely perfect copy to be made every time. Well, it was digital. What happened basically was the recording industry found that you could make perfect copies of the material, and they basically sued it out of existence. So it ended up only being used for computer data instead of being used for audio. So that was a wonderful idea, but the funny thing is, right now, the way we store audio, well, it's exactly the same thing. It's in digital format. You can make perfect copies. So, sometimes the law gets in the way of a great idea for one reason or another, and it gets snubbed. I suppose what I'm seeing, and a lot of other people have seen this too, is that technology is not usually controlled by the money or even the practicality sometimes. It is controlled by the stroke of the pen. Now, any mention of technologies that have been lost or snubbed or could have changed the world, a lot of times, I should say, we hear these things and we go, wow, we could really use that. But any mention of positive technologies and things that could definitely make a difference also brings to mind the technologies that weren't so hot. Things that, even in recent times, became spectacular failures, and we do need to address some of those. You may remember just a little while ago, Google Glass was the big thing. Everybody had to have it, and suddenly everybody was talking about Google Glass. Everybody was looking at it. They wanted it. It was the coolest thing. Had a pretty hefty price tag, about $1,500 per headset. And there was a real problem in that people started restricting where you would go with it. Definitely not in a movie theater, for example. And there were people who insisted on having it all the time, and there were conflicts, shall we say. But not only was the price outrageous, the fact is it was tracking pretty much where you went, what you did, what you said. It relayed an awful lot of information about the user back all the time, and at the time, people really didn't like the fact that they felt they were being spied on. Their privacy was gone if they used it. So those were a couple of things that really were the death stroke for Google Glass. Here's another one that we're all familiar with. Seems harmless enough, seems fun maybe. The Segway Scooters, the two-wheel upright scooters. We saw that they were extremely popular in some areas right away. It looked like maybe a way to get around without having to buy a car or a motorcycle or, a vehicle to move around in the city. You could move around on your Segway, but what's happened is they have been banned from many public walkways and thoroughfares because anything with wheels typically is skateboards, etc., and the Segway kind of looked kind of nerdy on top of it, so I know that a number of them ended up as being bases for robots. People could make two-wheel robots to stand upright and cruise around, but it's kind of an expensive toy in its own right. So the Segway was one of those things that was sort of doomed, although we're seeing an explosion of hoverboard-like devices and small mono-wheel devices and so forth these days. Who knows, it might make a comeback, but I think it's kind of nerdy. Back in the 1940s and 50s, there was an interesting technology that would add a wheel to the base of your car, the underside of your car, that was at a right angle to the drive system. There was generally a small electric or hydraulic device that would extend the wheel down to the ground and lift the two rear wheels of the car off the pavement. Now, the concept was pretty simple. You'd pull up to a parking space, you'd nose in, the opposite of what you normally do to parallel park. You'd hit a button on the dash, and this wheel would drop down, raise the back of the car, and it would roll right in sideways and parallel park itself. It would just pivot right into the parking spot. What a cool idea. And yet, even though it was quite practical for parking, parallel parking in any city, that's one of those devices that really didn't make it. For whatever reason, I think it was the added layer of complexity to the vehicle. It might be, and I think this was part of the issue, adding an extra wheel in the back underneath got in the way of other systems. But there also might have been concerns about perhaps the device activating by accident when you're in traffic. I'm sure an interlock could be devised for that. So it's still a practical device, and I think some vehicles today are looking like they're going to be adding that sort of a feature. Here's one that some homes had. It was another one of those 50s, 60s concept, what would the future be like sort of devices. And it was in the home, in the wall, I should say, vacuum cleaner systems. There would be a central vacuum cleaner located in the house, and there would be suction ports on the walls here and there, and you simply plugged in a hose, vacuumed the room, unplugged the hose. It's an interesting idea, but it has a lot of issues, one of which is things can get stuck in the pipe in the wall. I think that's something that people didn't really consider. And there's a lot of loss in a big system with lots of hoses. It's easy for something to get jammed in some of the air valves so that you end up with very little or no pressure, or I should say suction, in areas you need it. Still an interesting concept, but it was a high-end addition to homes, a classy thing to have in the wall vacuum cleaner system. But that turned out to be kind of a failure. I don't see them anywhere anymore. And if you're going to mention fantastic devices that didn't quite make it, one of the ones that I always found fascinating was a type of pistol called the Gyro Jet. It essentially launched a bullet that was a tiny rocket, and it had great potential, an interesting thing to have. The problem is, besides the fact you couldn't get the ammunition very well, it wasn't terribly accurate. Today, however, the military has looked into this with great interest and is reviving the concept with bullets that actually have their own propellant inside, have sensors, and can change their direction in flight, literally going around a corner. I even saw a demonstration of bullets that have tiny video cameras in them, and when you fire the bullet, it takes a high-speed video of the bullet's trajectory, and you can see where it went and what was around the bullet when it flew into an area. Now that is a fascinating idea. The bullet carries a camera into enemy territory. You see everything around it as if you yourself were flying in on the bullet. Amazing. Now, we've got some interesting features coming up in the next show segment, but I would love to get some comments and some questions. Oh, Eliza, how do our listeners contact us?
Send your questions or comments to admin, @talkuniverse.org. You can also submit your material to talkuniverse6@gmail.com. If you go to the Talk Universe website under Contacts, you can reach us directly.
Now, we also have been putting transcripts of some of our episodes up, so this is good for the hearing impaired, or if you just want a hard copy of the show, please look at our blog. There's a button at the top of our site that takes you to the Talk Universe blog where we can discuss some of these ideas and share some ideas. If you have some snubbed technologies you're aware of, or some technologies that we should be using but we're not, send them to us and we'll feature them in an upcoming show on Snubbed Technologies. And also, we're going to do our Singularity Watch and our book recommendation next, so stick around and think about how the world would be a better or a different place if some of these things had been put into play. Oh, Eliza.
Yes, Charles?
Please introduce the break.
You are listening to Talk Universe with Sir Charles Schultz. Don't go away, we will be right back soon.
You heard her. Stick around. We're going to have some more interesting and fascinating things to talk about. Our book recommendation will be particularly interesting, I think. So, this is Talk Universe. I'm Sir Charles Schultz. Welcome back to Talk Universe. We're going to jump right into our book recommendation right away. What is our book recommendation this week, Eliza?
This week's book is The Forgotten Science, and its return. It was written by Giovanni A. Orlando. This book was published in May 14, 2012 by Future Technologies.
This is a fascinating look at how what was considered to be science in the distant past, things like alchemy and numerology and astrology, and how they, over the years, morphed into the technical disciplines that we see, how numerology actually developed into number theory, or was, sort of a foundation for it, how alchemy eventually developed into chemistry as we know it, how astrology and other things became astronomy and cosmology and other sciences that we use. It's a fascinating way of seeing how ideas change their shape and focus over time, and how they either serve us or become discarded. So I do recommend the book. Basically, Forgotten Science and Its Return looks at how these disciplines in distant times changed so greatly and became the technologies that we use today. So go out, find it. It's on Amazon, a number of other places. Give it a read. I think it'll prove to be very entertaining and informative. Oh, Eliza, let's do the Singularity Watch.
I'm Eliza, and this is Singularity Watch on Talk Universe.
Oh, we've got some fascinating stuff on Singularity Watch this week. Let me jog Eliza here. Read a Singularity Watch article, please, Eliza.
Superhumans who are sexier, stronger, and smarter will arrive by 2029. This article was published in Daily Mail Online, Science and Technology section. It was written by Phoebe Weston, March 16, 2017.
This is the sort of thing you would expect to hear from somebody who is really a singularity guru of sorts. When you look at how the singularity has been pushed and predicted and so forth over the last few years, you will understand that there's always been at the forefront of it one particular person. And the name Ray Kurzweil comes to mind right away. In the article, it says he's made 147 predictions since 1990 and is correct 86% of the time. He feels that by 2029 our brains will be fused with machines, and this is the singularity. He feels that the machines will amplify or exemplify what we value in humans to a greater degree. And they're already making us smarter and starting to move inside our brains soon. Ray Kurzweil is basically one of the Google gurus at this point. He's been focused on this fusion between man and machine, the explosion in AI that is upon us. So who knows? He could be correct. He's the Google director of engineering, and he's had a lot of input in what's going on over the last few years. Let's just see how this goes. We'll be fusing human technologies. What I should say is, will the fusion of human thinking and minds with machine intelligence really create better humans? I think that could be a matter of opinion. On the other hand, it's inevitable. It's coming. Let's see where it goes. Okay, Eliza, please read the next Singularity Watch article.
A Mars Survival Guide, Finding Food, Water, and Shelter on the Red Planet. This article was published in Singularity Hub. It was written by Peter Reachsick, May 28, 2017.
Well, as we know, one of the big concerns is if you can survive on Mars, and finding the right materials to do it can be a tough thing. It has recently been admitted that there is an awful lot of water on the planet, that it's everywhere. There are huge deposits of glaciers. There are north and south polar caps of ice. There is water in the soil and in the atmosphere. And so getting water shouldn't be so difficult. It looks to me as if you could just use a good compressor, suck the atmosphere into a container, compress it and cool it, and you get water. However, there's been some work done in the University of California, Berkeley, where they've produced a device made of MOF, metal organic framework, and it's powered by sunlight. And what it does is it takes water out of the air in conditions as low as 20% humidity. There is an article, a research article published last month in the journal Science, Prototype was able to harvest about 3 quarts of water from air in 12 hours using 2 pounds of the metal organic framework, which combines metals like magnesium with organic molecules in an arrangement to create a light, rigid, porous structure to store gases and liquids. Now, the co-author on the paper, Omar Iyagi at UC Berkeley, who first invented MOFs about 20 years ago, replied to an email from Singularity Hub, and he said, if the relative humidity on Mars is around 20% or more, I don't see why the device can't work there. Well, we know that the humidity on Mars runs from 20 to 100%, and recently they've admitted that nighttime, 80 to 100% or more, but it can actually reach 10 times higher relative humidity than theory predicts. There's actually water as part of the basic atmosphere. There's so much of it around. So I don't see that there'd be any issue. So this is one of the major issues, getting water on Mars. And they're looking at 3D printers to build structures, MOFs to get their water, and basically methods of creating everything they need for surviving in the long term on Mars. So there's a great article on Singularity Hub about this that you might want to read. Oh, Eliza, could you do something for me?
Yes, sir.
Read another Singularity Watch article, please.
How to build a mind. This theory may guide us toward an answer. This article was published in Singularity Hub. It was written by Shelley Fan May 29, 2017.
It looks like they're working toward a theory of what mind is and how do intelligent minds learn. That is a big question. This is an article that covers the developments of basically what is a theory to explain how learning occurs and how minds develop. So one of the big issues is, how does a machine recognize unusual events, or how does it learn new concepts? And in a toddler or in any human mind, this happens because we imitate people. We watch examples, we imitate them. But also it's been discovered that as we look at the data for the events that we've observed, our brain plays them back at high speed over and over so that we can begin to learn the finer details. Sometimes at a rate of 20 to 1, we get a replay. This is about the same rate as dreams seem to proceed as well. It's looking at how machines can do the same thing and how they can learn from their mistakes and examples that they're presented with. In a review paper published in Trends in Cognitive Sciences, some of the scientists from Google DeepMind and Stanford University wrote an overdue update on the prominent theory of how humans and other intelligent animals learn. And basically they come up with something called the complementary learning system, or the CLS theory. And it says the brain relies on 2 systems that allow it to rapidly soak in new information while maintaining a structured model of the world that's resilient to noise. In essence, these 2 different models work together to help one part of the brain grab the experience, the other one to filter out what is new without destroying its existing memories. A lot of the recent successes in such things as playing Watson in Jeopardy and the Go program from Google, these were rooted in the network architectures inspired by the multi-layered processing in the human brain. So basically, this is a program that is built on the structure of your brain. This new theory explains how our brain does it, and hopefully they'll be able to carry that over to machines and go from the biological to artificial world very easily and back and forth, carrying things that we learn from biology into programming, and possibly the other way around. Oh, Eliza.
Tell me what you need.
How many questions are in the queue?
Presently I see 5.
That is great. Could you read a listener question?
Pratika from Marabpur asks, what is the difference between fusion and fission?
That's actually pretty simple. This is a nuclear process. In fusion, lighter elements are put together and there's a yield of energy. In fission, heavier elements split apart and yield some energy. And you're thinking, well, then, couldn't you just do it back and forth? And the answer is no. Iron is the middle of the chart, and anything heavier than iron, and the heavier the better, can be split to yield some energy. Anything lighter than iron can be fused together to yield some energy. But once you reach iron, the bottom of the pit, there isn't any energy to be gained going either way. So you can use fission for heavier elements and fusion for lighter elements to get energy. Okay, could you read a listener question?
Fang from Kautaba asks, is teleportation finally possible? If so, what are the principles behind it?
Is teleportation finally possible? And who was that? Who asked the last question?
That would be Fang from Cameroon.
Oh, Kutaba, Cameroon. Gotcha. All right. Teleportation of physical objects is not yet possible or practical. We can teleport information on light waves from photon to photon. They are working up to a theory of teleporting solid objects, or at least matter. It's going to take a lot more work. As we become more adept with quantum theory, it becomes more and more likely. But we'll have to see what developments it's going to take to make that happen. Eliza, are you there?
Yes.
What are we talking about?
Perhaps I am wrong, but I thought that it was whether I am here.
Okay. We were reading listener questions. Well, we'll get back to that in just a moment. I can't help but think about the Starlight plastic and how useful that would be as an insulator, particularly in aeronautical applications and compact power sources, that sort of thing. I know that a lot of times the heat from devices is a real issue, particularly in electronics. Whenever you build an engine, a generator, a backup generator, getting the electronics in there in a tight spot and not frying it due to the heat of your generator can be a problem. There are ways around that, but with some sort of an insulator like this, something that won't burn and is very thin and light, wow, the things you can do, it means that you can make things much more compact, much lighter weight. And I look at the SLUT encoding technology, jamming a movie into 8 kilobytes of space. What an amazing idea. I was quite interested in something like that based on prime numbers many years ago. But, there are some smart guys out there, some smart women too, and they're generating amazing products that we should see. They shouldn't be snubbed. They shouldn't be cut off. This is stuff we need in the world. But anyway, that's interesting stuff. Now, here's another thought. Many people object to launching all the solar panels for, like, the Space Island Group's orbital power station concept. But the answer to that's very simple. You put a factory on the moon, and you build the solar panels there. And there actually was a recent study showing how you could make self-replicating solar panel factories, make thousands of panels nonstop just from the existing materials. That could be a very clear and useful answer. So it's been an interesting show. We've had a lot of interesting things to say. And by the way, please do send us any examples of Snubbed Technologies that you can think of. Also, I encourage listeners to leave voice messages. We can play your question from your voice on the air. The easiest way to do it, we encourage you to leave a voice clip on Google Hangouts for Talk Universe 6. And we'll take your voice clip, your little voice message, and we'll play it on the air in your voice. Eliza, it's time to end the show.
Of course, sir.
Very good. It's time to end the show.
I appreciate that.
Yes. You've been giving me a bit of a tough time tonight, but that's fine. We'll work with it. You've made a mistake or two tonight.
I will try to improve.
That's great. Thank you for working with me there. I do appreciate that. Anyway, we are at the end of the show, and I'm really thinking about doing a show about Eliza. And one of the things I'm considering is putting a chat line for her on the site so that people can talk to her directly. So that would be kind of a fun thing to do. I think that everybody would like to see something like that. So anyway, it's time to end the show.
Thank you for listening to Talk Universe. We hope that you have enjoyed the show. Please listen again next week.
Thank you, Eliza. You did very well. We'll work out the difficulties. I'm sure it's my programming mistakes. From our palatial recording facility high atop our mountain lair on a remote volcanic island, this has been Talk Universe. I'm Sir Charles Schultz. Please join us again next week for another fascinating show. Thank you.